Welcome to another episode of Everything Explained, where we dive into the fascinating world around us. Today, we're going to explore a topic that many of us cross every day, but might not think too deeply about: bridges. Specifically, look at how these engineering marvels withstand pressure and keep us safe while we travel across them. Let's start with the basics. A bridge is essentially a structure built to span a physical obstacle, like a river or a valley, to provide a pathway for vehicles or pedestrians. But what keeps these massive structures standing firm against the weight of traffic, weather conditions, and other pressures? It all boils down to a combination of design, materials, and engineering principles. When we talk about pressure, we're really referring to the forces acting on a bridge. These forces can come from various sources. First, there's the weight of the bridge itself, known as its dead load. Second, there's the live load, which is the weight of vehicles, pedestrians, and anything else that might be on the bridge at any given time. Finally, external forces like wind, earthquakes, and temperature changes can create additional stress. To handle these forces, engineers use several key principles of physics. One of the most important is the concept of tension and compression. Imagine holding a rubber band between your fingers. When you pull it, you're applying tension, and when you push down on it, that's compression. Bridges use materials that can withstand these forces without breaking. Let's take a closer look at some common types of bridges and how they manage these pressures. First, we have beam bridges. These are the simplest type of bridge, consisting of a horizontal beam supported at both ends. Think of a seesaw on a playground. When someone sits on one side, the seesaw tips, but the support at the center helps balance the weight. In a beam bridge, the weight of the traffic creates a downward force, which the supports at each end counteract. However, beam bridges can only span short distances without sagging or bending too much, which is why they often have supports in the middle, known as piers. Next up is the arch bridge. These bridges have a curved shape that helps distribute weight more efficiently. Picture a rainbow. It's strong because of its arc. When weight is applied to an arch bridge, the force is transferred along the curve and down into the supports at either end. This design allows arch bridges to span much longer distances than beam bridges while maintaining structural integrity. Another well-known type of bridge is the suspension bridge, like the Golden Gate Bridge in San Francisco. These bridges use cables hung between towers to support the bridge deck. The weight of the bridge and any traffic is transferred down through the cables to the towers, which then direct the forces into the ground. It's a bit like hanging a swing from a sturdy tree branch. The branch takes the load of the swing and the person sitting on it, allowing for a smooth and stable ride. Then we have cable-stayed bridges, which are somewhat similar to suspension bridges but use fewer cables. In a cable-stayed bridge, cables are attached directly from the bridge deck to the towers, forming a fan-like pattern. This design is efficient for medium spans and can handle the forces of weight and wind effectively. Materials also play a crucial role in how bridges withstand pressure. Traditional materials like wood and stone have been used for centuries, but modern bridges often rely on steel and reinforced concrete. Steel is incredibly strong and can handle tension well, while concrete is excellent for compression. By combining these materials, engineers create structures that can bear immense loads without collapsing. Now, let's talk about the role of engineering in bridge construction. Engineers perform a variety of calculations to ensure that a bridge can withstand the forces it will encounter. They consider factors like the expected traffic volume, potential weather conditions, and even seismic activity in the area. This involves using complex mathematical models and simulations to predict how the bridge will respond to different types of pressure over time. Another important aspect is regular maintenance. Bridges are continually exposed to elements that can wear them down, like rust, weathering, and even the vibrations from traffic. Engineers conduct inspections and maintenance to identify any potential weaknesses or damage. This proactive approach helps to ensure the safety and longevity of the bridge. In summary, bridges are incredible feats of engineering that combine design, materials, and physics to withstand various pressures. From the simple beam bridge to the grand suspension bridge, each type has its unique way of managing forces. By understanding how these structures work, we gain a greater appreciation for the engineering principles that keep us safe as we travel across them. So next time you drive over a bridge, take a moment to think about the complex engineering at play. Those steel cables, concrete supports, and carefully calculated designs are all there to ensure your journey is secure, Thank you for joining me today on this exploration of how bridges withstand pressure. Until next time, keep wondering about the world around you.